These are the topics we are going to cover for today's program. First one is, what is the difference between digital and analog signal? If you remember that in one of our previous videos we talked about that, so today is just a reminder. The second topic is how to get analog output from Arduino, on which pins. And the last topic is explaining how Fade Sketch is working based on the examples on Tinkercad coding. So let's start it. We see two different examples of analog and digital signals. So as you remember that in analog signal, we have continuous information. Analog signal is like voice or light or temperature, heat. So for those kind of things, the data is continuous. For example, the temperature now in this room is around 24 Celsius. In a couple of seconds later, that is 24.2 Celsius, something like that. So it's continuously changing. But a digital signal always has two steps, 0, 1, low, high. When you use a switch to turn on a light, it's jumping from 0 to 1 or low to high and stays as long as you don't turn it off. But analog signal is always changing based on the nature of that signal. If you remember Arduino Uno, we talked about that before, it has a couple of pins on the top side and a couple of pins on the bottom side. For example, analog input pins are on the bottom side. But on the top side, we use pin number 0 to 13, 14 pins only for digital purposes. For example, digital output or digital input. But we can use not all of them, only 6 of them, as a digital output. So if you look at these pins, close to some of them, we have a sign like tilde or wave sign. This starts from number 3, then 5, 6, 9, 10, and 11, 6 pins. At this moment, just we need to know that these pins can be used for analog output too. Okay, let's go to Tinkercad circuits and start a new project. And as always, we just go and change the name of the project. This is fading LED. So I'm going to Arduino. Fade project is one of the basic projects by default on Arduino. So I don't need to set up everything, just bring the project to the work plane and try to understand what's happening here. So let's run the simulation. So as you see, the LED fading up and fading out, fading up and fading out. The difference between fade and blink is, blink, if you remember, that was one time happening. I mean, turning on, turning off, turning on, turning off. But here it's gradually moving from too dark to too bright. Let's see what we have as a hardware. So it's very, very similar to blink project. We have an LED, longer leg, the positive leg, which is anode, negative leg, shorter leg, which is cathode. Cathode, the negative connected to ground, positive leg anode connected to the resistor, and resistor connected to Arduino. But if you see that we connected LED to number 9, and number 9 has one of those signs close to each, meaning that we can get analog output from this leg. And fading is, as you see, it's an analog, because it's gradually turn to bright and gradually come back to dark. Now let's look at the code. So first start with block coding and see what's happening here. We have loop, but it's count up or down. So this is from control. It's here, count up or down. We can use this command to count down or up numbers the first time when we're running this program, the brightness, which is a variable, has number 0, and meaning is the output on this pin is 0. Then it will be waiting for 30 milliseconds. So it's coming back and it's going up by 5. So now the brightness is 5. So it goes there, and pin number 9 has 5, but that doesn't mean 5 volt. It's respectively depends on the maximum number. So the maximum voltage is 5 volt and it's equal to 255. But anyway, this is not 0, this is a number, so it's gradually going up a little bit voltage. For example, suppose is 0.2 voltage, something like that. It gets more voltage and more and more and more. What's happening on LED? LED gets more power, so it's getting brighter and brighter to the end, which is 255, which is the maximum number, equal to 5 volt. So at that moment, the LED is in the maximum brightness. When it reaches to 255, then we go from this loop to another loop. Because it's finished this loop, it goes to another loop. In this loop, is fading out, is counting down, equal to fading out of an LED. So at the beginning is 5 volt and is gradually go down, 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 down to the end, which is 0. So 0 means 0 volt. So at that time, the LED is completely off.